Alright. Number 1, Tyler, tell me what I would do. First of all, what's the parent function?
That's absolute value.
Absolute value. Okay, how would you transform that?
You're going to go up 7 units.
Very good, because it's to the outside, so you move it up 7 units. Very good. Number 2, Alan, what function is that, buddy? Quadratic. What would you do with that one? Shift left 4. It's inside. It's opposite of what you think, okay? Abigail, number 3.
It's a quadratic.
Very good.
And you move down 3.
Good job, because it's on the outside, okay? Number 4, Juliet, what type of function is that, hon?
Alpha
Very good, and what would you do with that?
reflect across the
Very good, because the negative's on the outside, so you'll reflect across the x-axis. If it's on the inside, it's across the y-axis, okay? And when you reflect something about the x-axis, does it change the x-coordinates or the y-coordinates? The y-coordinates. When you reflect about the y, it changes to what coordinates? X. Very good. Keep that in mind. All right, number 5. Juliana, what would you do on that one?
Go right 2 and up 2.
Very good. What type of parent function is it?
A quadratic.
Quadratic. It originates from the quadratic family. Very good. Number 6, Dylan. What type of parent function are we dealing with? Very good. From left to right, what would we do? Okay, but what you got to do first?
You're going to stretch vertically by a factor of 3.
There you go. Stretch vertically by a factor of 3. When I stretch vertically, is that affecting the x's or the y's? The y's. You're multiplying your y value by 3, okay? And you got to do that first before you start moving right and left. That's why I'm saying you got to start from the left. All right, number 7, Kylie. What type of function is that, hon?
Quadratic.
Quadratic, okay. What's the first thing you would do?
Reflect across the x-axis.
Very good. And then stretch.
Add factor of 6 vertically.
Very good.
And then shift left 4 and down 3.
Very good. Now, there's some big questions. You said, Miss Chester, you said when you stretch by a factor of 6, listen to what I'm saying to you. Vertically, that you multiply the y's by that value. You said, Miss Chester, what if I just go ahead and multiply everything by -6 and not 6? Does that take care of my reflection and my vertical? It does. So if you start doing that and you want to multiply it by -6, it's going to take care of both your reflection and stretch and vertical at the same time. Does that make sense? And we're going to see that today. I just want to go and let your mind be marinating on that. All right, number 8. Derek, what function are we dealing with? Starts with R, ends in pole.
Ends with what?
It ends in coal. Starts with R, ends
Reciprocal?
in coal. Reciprocal, very good. Reciprocal. What were you going to do there?
You go,
First of all, my question is it in the inside or outside of the function?
it's on the outside.
I'm not going to scream at you if you get it wrong. Just what is it? Outside.
Outside.
Because the inside it'd be in the denominator with it. So on the outside it tells you move it what?
You're asking me.
Up and down, don't it?
Yes.
So that means you're going to move down through it, okay? If it's on the inside, it's right or left, okay? That light's driving me crazy, y'all. All right. Number 9. Holly, what type of function are we dealing with? Quadratic, very good. Matthew, what are we going to do to that function?
Reflect over the x-axis.
Very good. Then what?
Shrink.
Mm-hmm. Shrink by a factor of 1/5 vertically.
And then right 6 units and up 6.
Very good. Does everybody see that? Remember, stretching and shrinking deals when it's multiplication. If that 1/5 was on the inside, we would be stretching by a factor of 5 horizontally, okay?
Oh, 5?
Huh?
Did you say 5?
Yes. If it's on the inside, it's opposite of what you see. You would think shrink, but it's stretching and you flip it. Okay? If it's on the inside. You're going to see that today. Number 10. What function is that, Jackson Noah? Very good. Say it with confidence. What is it? Thank you. All right. Nick, tell me what I'll do there. Very good. Then what? And then? Very good. Are there any questions on your homework? We're going to still practice this today. All right, let's turn back to this from yesterday. Oh, yes. Remaining tests, pass them up. All right. Why don't you right now go on and graph the parent function for both 8 and 9? Go and just graph the parent. That's all I want you to do. Graph the parent. And when I mean graph, I want an exact graph. What some of y'all did on your quiz, which is my fault because it says sketch. Someone just did a rough sketch. When I say sketch, I want a good graph, okay? So that's a life lesson we're going to learn. You get your quizzes back on Monday. That's what I'm doing, because that makes this exact. All right. On number 8, we have the function. Right there. What's the parent function? Quadratic. Guys, I got so many different names for that on that quiz. I got everything from a squared function to square root. We got to know this enough. What is that function right there? We're not going to miss it again. We're not going to miss that function again. Go home and learn your vocabulary. That's quadratic. All right, so what does that minus do? Mm-hmm. And then you're going to move it what? Right 1 and then what?
Down 4.
Okay, I want you to try and then I want you to compare your answer with mine, okay? Now, or hey, let's do this one together because we need to reinforce. Hold on. Let's just do this one together. All right. If it's on the x-axis, can you flip it anywhere? No. I'm going to move it right 1, down 4. Oh my word, yes, sorry. I'm going to move it right 1, down 4. This is 1 away. Let's be 1 away down here from the y because the x-axis is line of symmetry. Or you can just think of it this way. This is point 1, 1. If it's reflected by the x-axis, it'd be 1, negative 1. So it'd be right there. Okay? Now, I'm going to move right 1, down 4. 1, 2, 3, 4. This point is 2, 4. If it reflects about the x-axis, we're going to be at 2, negative 4.
Oh, there's supposed to be a negative there?
Well, buddy, I'm talking about this point is 2, 4. So if I reflect it, it's going to be at 2, negative 4 now because your y value changed.
Oh, on the paper it doesn't have a negative though in front of the x.
Oh no, I'm dealing with the parent function right now, bud. This is just the basic parent function. I'm on number 8. I know there's not one in there. I'm just saying we're looking. Oh yeah, yeah, page 51. 2, 4, and now I'm going to 2, negative 4. Or you could think it's 4 away, 4 down here. Now I'm going to move it right 1, down 1, 2, 3, 4. And I'm right there. It's 1 away, 1 away. I reflected it. And I'm going to go right 1, down 1, 2, 3, 4. It's 4 away, 1, 2, 3, 4. Right 1, down 1, 2, 3, 4. And guys, you know it. You did it right here, because shouldn't this be symmetric here? Shouldn't this be like 1 away here, 1 away, because that's your line of symmetry for your parabola? So yes. So there's your transformation there. Yes, Tyler.
Are we going to have one that falls off the graph on the test, or is it going to be exact?
If it is, you're just going to come get graph paper and graph it. Oh, are there any question? Number 8. All right. Number 9. What's the first thing you would do? What's this 3 tell me I'm going to do? Stretch by a factor of 3. And then I'm going to move it to the what? Left 8. Now I'm going to teach you 2 ways to do this. I used to teach you how to make a table, and I'm going to still show you that, because sometimes you got so much going on that some people might need to visually see it, okay? But I'm going to first show you how you can do it in your head, and then I'm going to show you how to do it with the table, okay? You pick, but remember, you're not going to impress Miss Chester by trying to do it in your head. If you need to do the table, you're going to do the table, okay? So here's your 2. I'm going to show you first. Okay, I got my parent function here. I told you that 3 is going to affect the what axis? X or Y? Which one? Y. So you're going to multiply your Y coordinate by what? 3. What's your Y coordinate here? 0. So what's 0 times 3? 0. So I'm still at 0, 0, aren't I? So I'm going to move it over how many? 1, 2, 3, 4, 5, 6, 7, 8. I'm over here. Alright? This point is 1, 1, isn't it? I'm going to multiply my Y value by 3. So I'm at 1, 3 now. So instead of being at 1, 1, I'm at 1, 3. Then I'm going to move it left how many? 8. 1, 2, 3, 4, 5, 6, 7, 8.
So basically multiply x times 3.
No, your Y value by 3. Yeah.
Always multiply the y value.
Yes. If it's on the outside. Yes. Alright, now 4, 2. I'm going to multiply my Y value by 3. So instead of being at 4, 2, it's going to be at 4 what? 3, 4, 5, 6. Right up here. Now I'm going to move it left how many? 1, 2, 3, 4. Oh, I can't look up here and do this too. 5, 6, 7, 8. That's your new graph. You stretch by a factor of 3. When you stretch a rubber band, don't it get like this? Now, if you cannot do that in your head like that, you could always... So basically, I just took 1 point at a time, and I moved the point doing the math. Now, if you can't do it like that, what you could do, and this is how I've always taught it, but I decided that you're intelligent, some of us might can do it in your head. Make a table of your 3 points right here. And then, okay, so that 3 is going to affect your what values? Your Y. So I'm going to say 0 times 3 is 0. 1 times 3 is 3 times 2 is. Now this plus 8, that's moving right and left, isn't it? So that affects your what coordinates? X. And it's opposite of what you see. You see plus 8, but you're actually moving at what? So I'm going to add what to each of these? Negative 8. And then you just graph those 3 points, and those are the same points I got over here. So if you want to do it in the table form and then graph your points, you can do it like that. Does that make sense? Either way, I'm good with either way. Alright. Let's look at number 10. F of x equals 2 per parentheses, x plus 3 squared minus 1. What's my parent function, class? Quadratic. So let's graph that quadratic. Alright, so let's just talk about it. This is stretching vertically by a factor of what? 2. That's moving what? Come on, say it with confidence. Moving what? 3, and then what? So I'm going to take each point and do that whole process with it, okay? So if this point is negative 2, 4, I'm going to multiply my what? My x to the y value. Y. So 4 times 2 is? Everybody, 4 times 2 is?
8.
Thank you. So now I'm going up to negative 2, 8. 1, 2, 3, 4, 5, 6, 7. Oh, I'm right up here. Okay. Now I'm going to move it left how many?
3.
Oh, I just bled through that paper. 1, 2, 3, and down how many? 1. So I went up to 8, moved it left 3, down 1. My y coordinate here is negative 1, 1. I'm going to multiply my y coordinate by 2, so I'm going to be at negative 1, 2. Move it left 3, 1, 2, 3, down 1. Zero, 0. I'll multiply my y coordinate by 2. It stays at 0. Move it left 3, 1, 2, 3, down 1. 1, 1. I multiply my y coordinate by 2. I'm actually at 1, 2 now. Move it left 3, 1, 2, 3, down 1. 2, 4. Multiply my y coordinate by 2. I'm at 8 now. 5, 6, 7, 8. I'm up here. Move it left 3, 1, 2, 3, down 1. And that's your new graph. Now I'm going to show you how to do it by table, if you'd rather do table. So that's the mama graph, and the graph originated from that. Like I said, you can do this either way. It does not matter to me. So that is my original ordered pairs, guys, for that quadratic. So I'm about to do all this using this table here. And sometimes you might have to do 2 tables, sometimes you might have to do 3. Just whatever fits you. I'm going to multiply my y values by 2. That's 8, 2, 0, 2, 8. I'm moving it left 3, so that means I'm going to add a negative 3 to my x values. Okay, I need to make another table because I still got one more thing to do. I'm moving down 1. When I got moved down 1, so I need to add a negative 1 to my what values? Y. So I'm going to add a negative 1 to each of those. So that's be 7, 1, negative 1, 1, and 7. And then I check, is that what we graphed? Negative 5, 7, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, yep. Negative 4, 1, yep. Those are the same things I did there. So you can either do this or you can do it in your head like that. I do not mind. But if you do it in your head, you've got to take your time. Okay, so I'm giving you 2 options on that. Alright, are there any questions? Is it starting to click? I need to see a hand signal. Be truthful. You're not going to hurt my feelings. A hand signal. Okay, we're going to continue this on Monday. We're going to start with number 11. You got 5 homework problems on page 53. Turn to page 53. 1 through 4 are real easy. Number 9 is one like what we just did, okay? And we're going to continue this on Monday. But Monday's my last day on it. Does everybody got me? Okay, I had an idea for today. And since y'all are one of my all-time favorite classes, I just want to tell you that. Just don't let me down in the next 9 weeks. Let's take a game day picture. A serious picture and then a crazy picture. How about that? Okay. No, like I said, you don't have to be in the picture. But I thought in the spirit of game day, let's take a game day picture and then a silly picture. How about that? If you don't want to take the picture, you can take the picture. All right. Whoever wants to do it, let's do it. What time does this bell ring?
9:04.
Okay, we got 2 minutes. Let's go. Who wants to take the picture?
I can do it again if you want me to.
I don't think people's feeling it this morning, so we're all good.
Yeah, we only have like 30 seconds.
You have 5 homework problems you can get done before you leave today. You can go and have that.
Really? I even have to use it though.
Guys, look at this one for just a second. Never mind. Go ahead. Have a good day. Here, I'll take the photo. Thank you. Have a good one.
Do you have a key made?
A key made.
Can you stop recording?
A key made for the test?
Yes.
Yes, I do.
Okay.